Check it.
Okay, welcome back. Today we're talking about operations on functions. Now, when you hear the word operations in algebra, they're referring to arithmetic operations. Now, you might remember learning arithmetic back in middle school, or actually elementary school. And arithmetic was the part of mathematics that just dealt with adding, subtracting, multiplying, and dividing. They called that arithmetic. Back when you were a second grader, that was math to you. But math is a much bigger subject. Arithmetic is just adding, subtracting, multiplying, dividing, and we're going to be doing those four things with functions now. So we'll start off with adding and subtracting functions. So there's a special notation that you use when you're adding and subtracting functions. We're going to be using this like it is in the book here. You need to recognize what this means and what this means, because all I'm going to do on a quiz is just give you this and put an equal sign in front of it, and you have to know how to interpret it, okay? So, and on the homework, you need to write this in front of each one of your answers so I can tell which one is which. So the first one says f plus g in parentheses with the of x, just like you have f of x, g of x, this is f plus g of x. And they're asking you to add the two functions, and here you have f minus g of x. So here you're adding, here you're subtracting. I'm going to do the two problems at the same time just to show you how they're different. So for the adding, you have f of x plus g of x. And for the subtraction, you have f of x minus g of x. For f plus g, you're going to take f of x, which is x squared minus 4, and you're going to add 2x plus 1, the other function, like that. And here, for the subtraction, you have the same two functions. It's f of x, but this one's going to be minus g of x. So I started off by just writing the two functions down. Now, what's different between the two situations here is this one's going to be adding, and this one's going to be subtracting. However, this is going to be completely wrong, the way I've just done this. See, when you put a negative in front of just the first term here, all you're subtracting is the 2x. You're not subtracting the 1, okay? You're still adding the 1. You can see clearly that's still a plus and that's still a plus. So something is wrong here. Well, when you're adding, you don't really need to put parentheses or anything. This is not necessary. If you do this, in the next step, you'll have to drop the parentheses. So that's kind of a waste of time, okay? But for subtracting, you absolutely must put parentheses around the thing you're subtracting. Why is that? Well, when you put parentheses around this, you're saying you're subtracting everything here, not just the first term. So that means what you're going to do is you're going to distribute this negative to both of these terms here. And that's the difference. So for adding, just combine like terms. For subtracting, make sure you're putting parentheses around the thing you're subtracting and distribute the negative. Now, after that, they're both the same. You just combine like terms. So here we go. Well, we only have a single squared term, so bring it down. We only have a single 2x here, x term, bring that down. And we have a negative 4 and a positive 1. That becomes negative 3, and then box your final answer as usual. Okay, how about the subtraction? Well, we set it up correctly by putting the negative and the parentheses, the red stuff here. So our next line is to just copy this exactly the way it is, because this didn't change. But now negative in front of a 2x becomes negative 2x, and negative in front of a 1 becomes negative 1. You can see here, that was a plus 1, this is now a minus 1. And that only happened because we used the parentheses. Okay, so combine like terms now, just like we did up here. It's x squared, the only squared term we have. The only linear term we have here is negative 2x, so bring that down. And we have a negative 4 and a negative 1. They're both negative, so they give you a negative 5. Box your final answer. Okay, so that's adding and subtracting. Just remember, when you're adding, you don't need parentheses. And when you're subtracting, you do need parentheses around the thing you're subtracting. Okay, now we're going to take the same two functions, f and g, same x squared minus 4, same 2x plus 1, and we're going to try multiplying and dividing. Now we'll do these ones separately. We're not going to do multiplication and division at the same time because they're different. Now I want to point something out before I start. In the book, they use a dot for multiplication. You can either use a dot or you can just leave it as fg of x like this, okay, without a dot, because when two things are next to each other, it's multiplication. However, we're going to be doing something tomorrow, or sorry, in the next lesson, where we're going to have this little circle here. And this is not the same as the dot, okay? So this is f times g of x, and this is f of g of x, which is composition of functions, which is the next lesson. So I just want to point out that if you're sloppy, you might end up making one look like the other and create a problem. Since they're both in the same section, this could be an issue. So just understand that the bubble, if you see it, is not the same as the dot, and the dot is not the same as the bubble. Okay, so here we go. Now that we've said that, we can just move that out of the way. How do you do f times g of x? Well, it's the same idea. You still just bring down the x squared minus 4, the two functions, and the 2x plus 1. Now, just to recap what I said a second ago, which was if you're adding, just add them. If you're subtracting, then you need a minus and one set of parentheses. If you're multiplying, you need two sets of parentheses. Okay, so no parentheses, one set of parentheses, two sets of parentheses for when you go from adding to subtracting to multiplying. Okay, other than that, the setup is exactly the same in terms of how you write the functions out. Okay, and now you'll recognize this hopefully as distributing, aka FOIL, right? So we're going to distribute the x squared here, right? And what do we get? We get x squared times 2x is 2x to the third power. X squared times 1 is just x squared. Okay, we're done distributing the x squared. Now let's distribute the negative 4. Negative 4 times 2x is negative 8x, and negative 4 times 1 is negative 4. And now, any like terms here? Actually, no like terms. Different power of 3, 2, 1. So we're done. And there you go. That is f times g of x. Finally, there's division. And the notation for the division is f over g of x. Okay? So when you see this f over g, they're asking you to divide. And the first step is actually pretty simple. Whatever f of x is, put it on top, and whatever g of x is, put it on the bottom of a fraction. So the functions were x squared minus 4. That was f of x, and g of x was 2x plus 1. Okay? Now, there's a couple of things you have to do after you stack them like this. So stacking is the first step. If this was a 3-point problem, you get the first point for doing that. Now, what else do you have to do? Well, if you have a fraction like 4/6 and you box that as your final answer, I'm going to mark it wrong because it's not reduced to lowest terms. You have to reduce or simplify your answers as much as possible. And what's going on with 4/6 is that it's not in lowest terms. It should be 2/3. Now, how do you get 2/3? What you do is you factor, okay, you find a greatest common factor between the numerator and denominator. So 4, let me go back to 4/6 here. 4 is 2 times 2, and 6 is 2 times 3. They have a factor in common, so you cancel out the common factor, and there's your 2/3. That's how you reduce the lowest terms. You find a factor they have in common, and you cancel it out because 2 over 2 becomes 1, and 1 times 2/3 is still 2/3. So you look over here, and you say, do they have a common factor? And the easiest, well, not the easiest, but the most obvious thing they do here is to fully factor the top and fully factor the bottom. Now, the bottom doesn't have a GCF, and the bottom, honestly, is not factorable, so you can't do anything with the bottom. The top is a difference of squares, so you have x plus 2, x minus 2 if you factor it. Does this cancel out with anything? Not really, no. Only if there was an x plus 2 or an x minus 2 in the denominator. So what you do is, the idea is factor the top, factor the bottom. If they have anything in common, cross it out, and then you're done. Now in this case, nothing cancels out, so this is actually our answer right here. Now in the textbook, they also require you to give the domain of this fraction. Okay, we haven't learned about domains in full yet, so I'm not going to go into this. But in the answer key for the homework, you're going to see stuff that looks like this. It's going to say, this is going to be the answer, and then it's going to say x is not equal to -1/2. And you might wonder where that comes from, that extra little thing they add on to the answer. Where that comes from is a denominator. I'll talk about it briefly, but a denominator can never equal 0, never be 0. Okay, because you can't divide by 0. Take out your calculator, divide any number by 0, it'll give you an error. Dividing by 0 is not a thing. Okay, it's not possible. So you may not have, you cannot have a number down here that will create a 0. So imagine if this down here was -1/2. 2 times -1/2 would be -1. And -1 plus 1 equals 0, and that's a problem. You can't have a 0 in the bottom of a fraction. So x can be anything it wants to be, any number in the universe except -1/2. So we say x cannot equal -1/2. And if you're wondering, well, how did I know about this -1/2 thing? It's really simple. You just take the denominator, whatever the denominator is, take it off to the side and set it equal to 0 and solve. So you subtract 1 from both sides, you get that. You divide both sides by 2, and you get that. That's the one number that will make this denominator equal to 0. So you say x can never not equal that number. Okay? But like I said, I'm not going to focus on that. It's going to be in the homework answer key. I'm just not going to focus on it yet because it's coming up in a later section. So there's your answer for the division. Stack them first, just to recap because I talked a lot. Stack them first, then see if you can factor and cancel anything. If you can factor the top and the bottom and something cancels out, great. If not, then you're done. Okay. All right, so let's do a little more of this division stuff, okay? Because we did the adding, subtracting, and multiplying. That was pretty straightforward. Adding, you're just combining like terms, like up here. Subtracting, you're distributing a negative on the second half and then combining like terms. Multiplying is just multiplying the way you've been doing it all your life. Dividing is, like I said, a little more complicated because you start by stacking, which is really super easy. Just put top and bottom. But then you have to look to see what else you can do, all right? And so let's do a few examples here. Let's say you stack these two on top of each other. Okay, you're doing f over g of x, and you get this. Are you done? Can you just box your answer? Well, we have to look for common factors to see if we can if we can simplify anything here. So let's see. On the bottom, we have a 6x squared. On the top, we have 2x squared plus 4x. So if you think about it, there's definitely a 2 in both of these terms here, and there's definitely an x in both of these terms. So the GCF on top is 2x. Now, what happens when you pull a 2x out of each one of these? You're left with an x plus 2. Sorry, x plus 2. And check it. 2x times x is 2x squared. 2x times 2 is 4x. Okay, that works. The bottom is 6x squared. Do you see anything we can cancel? And the answer should be yeah. See this 6x squared on the bottom? Isn't that really 2x times 3x? Right? That will give you 6x squared. That means there's a common thing that you can cancel out. And now you have x plus 2 over 3x. And that's a fully simplified, it's called a rational function, okay? Which is a fraction, a polynomial on top, a polynomial on the bottom, okay? So you're going to be, every time you do a division problem, like the one we did here, where you put a function on the top and the function on the bottom, before you box your answer. Now, in this case, there was nothing to do and nothing to reduce. But before you box your answer, you have to try to factor and see if anything cancels. All right, how about this one here? All right. At first glance, it doesn't look like anything cancels out because the top and the bottom don't match. But if you notice, the top is actually a difference of squares, which factors out to be x plus 3, x minus 3. Hopefully you recognize differences of squares nowadays pretty quickly. And the bottom is exactly like one of the factors. It's x plus 3. So this is going to cancel out. Okay, now what we mean by cancel out is that this becomes a 1 because something over itself, 5 over 5 is a 1, 17 over 17 is a 1, right? Negative 0.403 over negative 0.403 is a 1. So because these cancel out, you have this now over just a 1, which is just x minus 3. And that's your answer. Okay? You don't need to have the over 1. Anything over 1, you should get rid of the over 1 part and just make it a whole number. Okay, how about here? All right. Well, it looks like something might cancel out. It looks like you might be able to cancel out the 25s or maybe one of the x's. But the fact is, this one cannot be reduced at all. It is done. Okay? It's basically not a trick question, but the top looks like it might be factorable. It would be factorable if it was x squared minus 25. That would be a difference of squares, and you could factor it as x plus 5, x minus 5. But even if you did have that in the top, the bottom still doesn't cancel out because it's x plus a different number. So that wouldn't work anyway. But the fact that it's x plus 25 means it's not even factorable. And the bottom isn't factorable. And here's the thing. If you can't factor something, if you can't factor it, you can't cancel it. So you might say, hey, there's a 25 here, there's a 25 here. Well, can you factor a 25 out of the top? No, because there's not a 25 in both terms. Can you factor a 25 out of the bottom? No. If you can't factor it, you cannot cancel it. That's a rule that you need to learn before you leave Algebra 2 and go to pre-calculus, or even just for the rest of this year too. So only cancel out things that can be factored out. Notice here, can I factor out an x plus 3 out of both the top and the bottom? Yes. Okay. I mean, you might say, well, there's only x plus 3 down here. How could you factor it out? Well, you could look at it this way. I know I'm going back to a previous problem here, but you can think of it as x plus 3 times 1. There you go. That's now, they're factors now. And that's why these two cancel out. So we can factor out x plus 3 on the top and the bottom, and that's why we can cancel them out. Here, you cannot cancel out the 25s because you can't factor them out. Okay, and this is a big mistake that I see even in AP Calculus students that I teach. So don't do it. If you want to cancel you ever want to cancel something out in a fraction, check to see if it's factorable first. Okay, so this one's not factorable at all. This one's done. Okay, how about this one here? Well, the top, if you look at it, this looks like it's factorable. I think it's reverse FOIL, right? So let's see. We have an x and an x, right? Two numbers that multiply to give me negative 15 would be 5 and 3. That also add to give me negative 2, negative 5, positive 3. We've used this particular trinomial a lot, so hopefully you recognize it. How about over here? Well, this one, before you get into the AC method to try to factor it, you might realize, hey, there's actually a 2 in all of these. So the first thing you want to do is go take out the GCF. And that gives you x squared minus 4x minus 21. And then that, I think that's factorable without the AC method. So a lot faster if you just use reverse FOIL. Okay? Two factors of 21 that give you, well, first of all, put your x's down. Two factors of negative 21, 7 and 3. That would add to give you negative 4, so negative 7 and positive 3. And there you go, right there. So the top is fully factored, the bottom is fully factored. Do they have anything I can cancel out? Yes. X plus 3 yet again. So what's my final answer here? X minus 5 survives on top. 2 times x minus 7 is left on the bottom. Okay, so x minus 5, and the bottom is 2x minus 14, and that's that. Okay? If you can't factor it, you can't cancel it, but if you can factor it and they match, these become a 1. This part of the fraction becomes a big fat 1 right here, right? And so it disappears because 1 times anything just isn't, visible. All right, let's go on to this next one here. The top is not factorable. It's not a difference of squares, it's actually a sum of squares. The bottom is factorable. So the bottom is x plus 1, x minus 1, difference of squares. The top, you might be tempted to factor, might think it's like x plus 1 times x plus 1 or something. But if you did multiply these, you get x squared plus 2x plus 1, which is not the same thing. So no, the top isn't factorable. The bottom is factorable, but nothing matches. So this one's done already. Okay, but you must check because you don't know until you try. Okay, so we have this one here. Now, at first glance, you might not really see anything you can factor out. Please don't tell me that you're going to cancel those out. That doesn't work because you cannot factor out a 2 out of the top and the bottom. If you can't factor it, you can't cancel it. But the top is a trinomial, and we do know how to factor trinomials, so maybe we can factor this trinomial somehow. And now, there's no GCF, so it looks like we're going to have to use the AC method here unless we want to do a lot of guessing and checking. So the AC method is A times C is 30, right? So AC is 30, A times C is 2 times 15. We need two factors of 30 that two factors of 30 that add to give me 13. So 10 and 3 comes to mind, right? 10 and 3. 10 times 3 is 30, and 10 plus 3 is 13. Actually, that's perfect right there. So that means the 2x squared plus 13. Notice I'm doing my scrap work off on the side, not messing with my main graded work here. So plus 13x becomes, instead of 13, it's going to become 10x and 3x, right? Plus 15. And now from here, you can factor by grouping. Right, that's what the AC method is, just turning a trinomial into 4 terms so you can factor by grouping. The GCF here looks like it's going to be 2x, leaving you with an x plus 5, right? And here, well, in order for factor by grouping to work, this also has to be an x plus 5, right? So I'm going to start with that assumption and say, oh, is there a number that I can put here that would make this true? And yeah, it's 3, right? Positive 3. And if you distribute that, it checks out. So my factorization is 2x plus 3, x plus 5. So I'm going to put that up here. 2x plus 3, x plus 5. Now the bottom is 2x plus 3. Can I factor out a 2x plus 3 out of 2x plus 3? Yes, I can. If I factor this out, it becomes 2x plus 3 times 1, right? Because you factor out 2x plus 3 from here, all that's left is 1. And now you see you have a greatest, sorry, not you don't have a greatest common factor, you have a common factor on the numerator, in the numerator and the denominator. So that leaves you with just x plus 5 over 1, which is just simply x plus 5. Okay, we're good. See you at the next video.
Check this.